Hey, welcome back. In this episode, we're going to learn about managing code quality and security policies. My name is Sushant Sutish, and I'm your trainer for this AZ-400 Azure DevOps Engineer Expert Certification course. So, without wasting any more time, let's get into it. Let's start with understanding how can you manage code quality. There are 5 key traits to measure for higher quality. The first one is reliability. Reliability measures the probability that a system will run without failure over a specific period of operation. It relates to the number of defects and availability of the software. Number of defects can be measured by running a static analysis tool, and software availability can be measured using the mean time between failures. And low defects counts are especially important for developing a reliable code base. Second trait is maintainability. Maintainability measures how easily software can be maintained. It relates to the size, consistency, structure, and complexity of the code base. And ensuring maintainable source code relies on a number of factors such as testability and understandability. You can't use single metric to ensure maintainability. Some metrics you may consider to improve maintainability are the number of stylistic warning and complexity measures. Both automation and human reviewers are essential for developing maintainable code base. The third trait is testability. Testability measures how well the software support testing efforts. It relies on how well you can control, observe, isolate, and automate testing, among other factors. And testability can be measured based on how many test cases you need to find potential faults in the system. And the size and complexity of the software can impact testability as well. So, applying methods at the code level, such as cyclomatic complexity, can help you improve the testability of the component. The fourth trait is portability. Portability measures how usable the same software is in different environments. It relates to platform independency. This isn't a specific measure of portability, but there are several ways you can ensure portable code. It's important to regularly test code on different platforms rather than waiting until the end of the development. It's also a good idea to set your compiler warning levels as high as possible and use at least 2 compilers. Enforcing a coding standard also helps with portability. And the last trait is reusability. Reusability measures whether existing assets, such as code, can be used again. Assets are more easily reused if they have characteristics such as modularity or loose coupling. Reusability can be measured by the number of interdependencies. Running a static analyzer can help you identify these interdependencies. Let's look at the quality metric. While there are various quality metrics, the important 2 metrics are defect metrics and complexity metrics. In defects metrics, you will define the number of defects, and the severity of these defects are important metric of overall quality. Complexity metrics can help in measuring quality. Let's look at some of the common quality related metrics. These are the following list of metrics that directly relate to the quality of both the code being produced, of the build and deployment processes. Failed build percentage gives you overall what percentage of builds are failing. Failed deployment percentage gives you overall what percentages of deployments are failing. Ticket volume defines what is the overall volume of customers or bug tickets. Bug bounce percentage indicates what percentage of customer or bug tickets are being reopened. And unplanned work percentage indicates what percentage of overall work being performed is unplanned. Now let's understand what is technical debt. Technical debt is a term that describes the future cost that will be incurred by choosing an easy solution today instead of using better practices because they would take longer to complete. The term technical debt was chosen for its comparison of financial debt. It's common for people in technical debt to make decisions that seem appropriate or the only option at the time. But in so doing, interest acquires. The more interest that acquires, the harder it is for them in the future and the less options that are available to them later. With financial debt, soon interest acquires on interest, creating a snowball effect. Similarly, technical debt can build up to the point where developers are spending almost all their time sorting out problems and doing rework, either planned or unplanned, rather than adding value. So let's look at some of the sources and impacts of technical debt. First one is lack of coding style and standards, lack of poor design for unit test cases, ignoring or not understanding object oriented design principles, monolithic classes and code libraries, over engineering code, insufficient comments and documentation, not writing self documenting codes, taking shortcuts to meet deadlines, and leaving dead code in place. Please note that over time, technical debt must be paid back. Otherwise, the team's ability to fix issues and to implement new features and enhancement will take longer and longer and eventually become cost prohibitive. To find other code quality tools that are easy to integrate with Azure DevOps, search for the word quality when adding a task into your build pipeline. That concludes this episode. In the next episode, we're going to look into Module 7 Knowledge Check. I will see you in the next one. Until then, take care.